Assalamu alaikum. So today we are going to talk about the instruction set architectures, and basically we are going to talk about the RISC computer. And the RISC computer is basically the reduced instruction set computer. Okay, it is the reduced instruction set computer. So the characteristics of the reduced instruction set computer, basically it has load and store memory access. It has 4 addressing modes. It has a single instruction format length, and the instructions that are required are only elementary operations. So it's basically a single cycle computer with a pipeline. A single cycle computer that we studied earlier with the pipeline. Now, the instruction set architecture over here in the RISC computer, we are going to talk about 32 registers. Okay, it contains 32 registers, and these 32 registers are accompanied with the program counter. And registers R0 is a special purpose register. Register R0 is a special purpose register having the value of R0 equal to 0. So now our register file will contain 32 registers. So the size of the programmer accessible register file is large in the RISC, where you have 32 registers. Since the data manipulation operations can use only register operands, many active operands need to be present in the register file. So in addition, we have the program counter, which is used to point to the next instructions to be executed. So the instruction format now has 32 bits instead of 16 bits compared to the register file. This longer word length will have a realistic value as we see over here. Now, the first format, as you can see here, is the 3-register format, where we have the opcode, which is having 7 bits. We have the destination register, the source address, and the source address A and the source address B. The second format, which is the opcode with the destination registers SA and an immediate value of 15 bits. Then we have the branch, which has the DR and SA as 4, 4, and here we have, as you can see, 15 bits for the offset target. So the first format has 3 registers. 2 registers are addressed by 5 bits. Sorry, 5 bits, not 4 bits, because we have 32 bits, so we have 2 to the power 5, which is 32. And we have the third address, which is 5 bits. Okay, and we have the 7 bits as the opcode to provide the maximum operations. So the second, so the register file, the opcode is 7 bits. Each register has 5 bits, and this leaves us with 15 bits for the immediate and offset targets, as you can see here. So this one is 15, this one is 5, this one is 5, and this one is 7. So in total, this is 32. When it comes here, these from 0 to 9, they are not used. We can neglect them. So we have 5, we have 5, we have 5, and we have 7. Here we have 15, 5, 5, and 7, as you can see. So the target address is formed by adding the contents of the program counter to the offset address. Of course, remember, like last time, we use extended value, where we fill the most significant bit. If it is 1, we fill with 1s. If it is 0, we fill with 0. Finally, over here, the right 5 most bits of the 15 bits constant are also used as the shift amount for multiple shift rights and shift left. So in table 6.1 shows us the operations that we have. NOP, or no operation, is done over here, and the NOP is used for pipelines to reduce hazards. We have move A, add, subtract, and, or, XOR, not, add immediate, subtract immediate, and immediate, or immediate, XOR immediate, add immediate unsigned, subtract immediate unsigned. All of these instructions, as you can see, these are the reduced instruction set operations. This is part 1, remember, okay? So as you can see here, this is sign extended, okay? This is sign extended. This is zero fill. When we have 0 or with immediate, it's zero fill. When we have SE, it means sign extended. Now, since the immediate value, okay, we have sign extended and immediate value as we saw here. This is part B, where we have move B, logical shift right, logical shift left. We have the load, we have the store, we have jump, we have set if less, we have branch on 0, branch if not 0, jump and link. All of these are the instructions which constitute the reduced instruction set computer. Now, if you look at them, move B is again once more it's done through the shifter inside the function unit, if you recall. Then we have shift right and shift left, shift right and shift left by SH bits, and these bits, the SH bits are here. They are the 5 most bits of the constant. Okay, 5 most, the rightmost 5 bits of the 15-bit constant that are used for the shift right and shift left. So these are the 5 bits over here if we use shift right and shift left, or over here if we use shift right and shift left. The instruction, these are the 5 bits over here. They are used for shift right and shift left. Now, when it comes to load and store, they are straightforward, nothing new. Jump is straightforward, nothing new. We load RSA into program counter. Then we have set if less. If RSA is less than RSB, then we put 1 into RDR. This is a new instruction. Set if less. If RSA is less than RSB, then we are going to put 1 into RDR. Then we have the branch if 0, branch if not 0, jump, the normal jump, okay, and we have jump and link. Now, now if you look here, what is the difference between jump register and jump? In jump register, we take an address from the register file and put it into the program counter. It's unconditional jump. When we talk about jump, the normal jump, we take an immediate value and add it to the program counter. So this one, we can talk about it as unconditional branch. So this is a branch of 0, branch if not 0, unconditional branch. This one is jump, we load a new address, and this one jump and link. In jump and link, we jump unconditionally, but we save our current location in the RDR. We have a way to go back, and this is very useful. If you recall when we talked about in assembly language, when we called a subroutine. Okay, when we called a subroutine, this is very useful to come to return instruction. Now, this is the set if list. We talked about all of these instructions. So now the addressing modes in RISC are 4 addressing modes, which are register, register indirect, immediate, and relative register mode. So the mode of are specified by the operation code. This is the register file. This is the data path that we are going to use, and this data path, as you can see over here. First of all, our register file is 32 by 32 because now we have 32 registers. We have AA, we have BA. Now we have mux A, we have mux B. In mux A, we have PC-1 and we have MA. Over here, we have the modified function unit where we have SH 5 bits, function unit 5 bits. We have the the N negative and overflow bits with the carry. You can see the N and V are applied here for the overflow. And as you can see here, we have our memory present for the data memory. Our instruction memory is present over here. This is the circuit mux C is used to control the program counter, whether we are going to increment or whether we are going to branch, depending on the values. Here is PC. Here is PC minus 1, this is PC minus 2 to preserve the program counter, because when it comes to the adding and finding the branch address, we need to know all the values throughout over here. This is the constant unit. Now the constant unit will either do sign extend, or it will zero fill depending on the values that we are going to talk. So this is the end of part number 1. In part number 2, we are going to discuss more in details about this data path.